In this video, we're going to talk about what we call the slope of a line. All right, I'm going to draw a couple of lines here. For instance, I can have a line like that, or we can have a line like that. This is an example of a line, and that's an example of a line. And what's true about all of these lines is that they have one specific feature that is unique to each of them individually, and that's the slope of the line. All right, if you notice, some of them are going up, some of them are going down, some of them are going up more, a little bit more quickly than the other, some are going down a little bit more quickly than the other. All right, and that is what we call the slope. It is the measure of how steep that line is. The measure of how steep that line is. Not only do we want to know that definition, but we're also going to want to know how to interpret slope. All right, and basically, slope explains how the value of y, your y variable, changes with each 1 unit change in x. All right, and that's what we're going to use in order for us to interpret the meaning of slope in the context of problems. Let's go through and develop the formula for calculating the slope of a line. There are many definitions, but this is one of the generic ones, the measure of how steep a line is. One way to get that is to be able to figure out what the vertical change, remember vertical means up and down, so to go from one point to the next, determine how many units you go up or down, that's what I'm calling my vertical change, and I'll divide that by my horizontal change, and that's going from one point to another point on that line. How many units do I go to the right or to the left? All right, since vertical is with respect to the y-axis, some people call this delta y, and that delta symbol just means change in y. And then delta x divided by delta x, that's your change in your x's, since your x's are horizontal and your y's are vertical. All right, and so what I'm going to do is I'm going to eventually get to the actual formula for slope. But in order for me to do that, let's go ahead and calculate the slope of this line that I have plotted here. In order to find the slope of a line, you need at least 2 points, just like you need at least 2 points to draw a line. And so what I'm going to do is, out of the blue, I'm just going to pick 2 points that this line goes through. For instance, it goes through the point 3, 2, and it also goes through the point 5, 6. All right. Now, in order for me to calculate slope, remember, I have to do the vertical change over the horizontal change. And what I mean by vertical and horizontal change, let's start with vertical. How many units up or down do I go in order for me to get from one point to the other? For instance, if I look here, I can draw a triangle this way. All right, and that'll kind of help me see how many units I need to go up and how many units I need to go over to the right. So if I count here, I need to go 1, 2, 3, 4 units up. So that means my change in my y values would be 4. And I need to go from that point 1, 2, 2 units to the right. And I get 4 over 2, which simplifies to 2. All right. And I could also do it going here, drawing my triangles this way, all right? It really doesn't matter, right? You still see that you have a vertical 1, 2, 3, 4, and you still have a horizontal of 1, 2, all right? Now, one way for us to do this with using a formula, because we're not always going to be given a graph, we won't always want to use a graph, is to use a formula. And basically, this formula is going to come from just naming these points generically, all right? I'm going to name this first point, I'm going to name it x, y, and I'm going to name the second point x, y. Now, in order for me to tell the difference between the x's in this point right here and the x's in that point right there, I'm going to call this point x1, y1. I'm going to put a little subscript, and I'm going to call this x2, y2. And that way, I can distinguish between the 2 points. Now, if I want to find the change in my y over my change in my x in order for me to find my slope, then all I have to do is subtract my y value. So I'm going to say y2 minus y1. And I'm going to divide that by my horizontal change, which is in my x's. I'm going to say x2 minus x1. Now, if I did this for these points here, remember, this is the point 5, 6. And this was the point 3, 2. Then all I have to do, if you look at the y2, that's 6, And the y1 is 2, 6 minus 2, over the x2, which is 5, minus the x1, which is 3. And there again, you see that 4 over 2. So this formula really does work. It'll help us be able to find the slope. So this is something that you're going to want to memorize. And all it is doing the change in y over the change in x. All right, let's look at an example here. I'm just going to look at this first example where it says we have to find the slope of the line that's passing through the following points. And I'm not going to do that example there. All right. Well, I have the point -2,5 and the point 4,7. Well, I'm going to label the -2,5 my x1, y1. And I'm going to label this one x2, y2. And so remember our formula for slope. You do y2 minus y1, your vertical change, over your x2 minus x1, which is your horizontal change. And my y2 is 7, my y1 is 5, so I get 7 minus 5. My x2 is 4, my x1 is -2. So I get 7 minus 5, which is 2, over 4 minus a -2, which is 6. And so I get that the slope of that line is 1/3. All right, and so this formula is going to be valuable because it allows us to calculate the slope without having to draw the line and do the actual going up and down to find the slope. All right. Now I have some horizontal and vertical lines here. In these examples, we want to find the equation and the slopes of the following lines. In part A, I have a horizontal line. Remember, anytime we have a horizontal line, it's always in the form y equals some number. All right. And to figure out what that number is, we go on our y-axis. And if you look, on my y-axis, this line goes through -4. So the equation of that line is y equals -4. Now we need to find our slope. Okay? In order for us to find our slope, you can choose 2 points on your line and you can use that slope formula. All right? What I'm going to do is I'm going to tell you that the slope of this line is 0. All right? And the reason why that slope is 0 is because, hey, if I pick another point, I'm just going to pick a point out of the blue, right? Remember, you can do your change in y or your rise over your change in x, right? Well, your y values are the same in both of these points. This is the point 0, -4, and this point right here is 2, -4. And so my change in y is going to be 0, and my change in x is 2. Well, 0 divided by 2 is 0. All right. So the slope of this line is 0. And this is going to be true for every single horizontal line. They have no slope. Right. You're not rising or you're not sloping any. Right. You're just going to the right and left. All right. This is a vertical line in part B. And the slope or the equation of the line when we have vertical lines is always in the form x equals some number. All right, and to figure out what number it is, we got to go to our x-axis, and it crosses the x-axis at 3, so the equation of that line is x equals 3. Now I got to find my slope. All right, and if you want to use m instead of writing out the word, that's perfectly fine. To find the slope of this line, what we need to do here is you can pick 2 points. Let's say I pick this point here, and I'm just going to go ahead and tell you the slope is undefined. All right. And that's because, remember, your slope is change in y over your change in x. I'm going to go up here. Well, this point right here is the point 3,0, and this point is the point 3,3. And so my rise would be something like 3 minus 0, which is 3. And my run, I'll do my change in my x's. Well, 3 minus 3 is 0. So we would be divided by 0 if we were to find the slope of this line, and that's why I call it undefined. All right. So the slope of this and every single vertical line is going to be undefined. Now we want to be able to get to graphing. In order for us to get to graphing, we're going to have to use more than just the slope. And this is where one of the most popular equations of lines come into play. The slope-intercept form of the equation of a line. It is one that most people memorize. Y equals mx plus b. M is your slope, hence the word slope in the name. And B, it is an intercept, but more specifically, it is your y-intercept. And so if I look at the equation of a line that's solved for y, I can explicitly see right there in my face what the slope of that line is and what the y-intercept of that line is. Let's look at some examples. In part A, it says identify the slope and the y-intercept. Well, if you look at this example up here, whatever is multiplied in front of that x is your slope, m, and whatever number is sitting out there on the outside that's not multiplied by x is your y-intercept. And so if I look at this example, my slope, notice the 2/3 multiplied out in front of the x, my slope is 2/3. And my y-intercept is -7. And of course, your y-intercept is a point, and so there are times where we want to write it as an ordered pair. It'd be the point 0, -7. All right, so that's coming up with an equation, or given an equation, you should be able to identify what the slope and the y-intercept are. Let's go to part B. It says find the equation of a line that has a slope of 5 and a y-intercept at 0, 6. So what they're giving us here, they're telling us when they say the slope is 5, they're telling us that m is 5. And when they give us that the y-intercept, they have a y-intercept at 0, 6, they're telling us that b is 6. And so if I have my equation as y equals mx plus b, and I have my m and I have my b, then I have the equation of a line. So all I'm going to do is put 5 in for m, so I get 5x, and 6 in for b, and I get y equals 5x plus 6. And that is the equation of this line. So not only can you identify the slope and the y-intercept, but if I give you the slope and the y-intercept, I expect you to be able to come up with the equation of a line. Let's continue, right? One of the things that this equation of a line y equals mx plus b does for us is give us another way to graph an equation of a line, all right? And this is going to be graphing using the slope and the y-intercept, all right? What we're going to do first, once we get y equals mx plus b, the first thing we're going to do is we're going to plot the y-intercept. We're going to plot the y-intercept. After we plot the y-intercept, we're going to use the slope to find another point on the line. All right? So remember, our slope is our change in our y over our change in our change in x. Or as some people like to say, the rise over the run. And so if we know our y-intercept, then we just rise and run in order to find another point on our line. And that'll give us the second point that we need in order to draw the graph. And so the last step is to plot the line that passes through those points. Let's look at any. All right. In this example, we have y equals -2x minus 1. And if you notice the instructions here, graph using the slope and the y-intercept. Well, if I'm going to graph using my slope and my y-intercept, then I need to know what my slope and my y-intercept are. And notice this equation is solved for y, so it is in y equals mx plus b form. And so my slope, if you look at it, the number multiplied by the x is -2. All right. And my y-intercept is -1. Okay. Now looking at the slope, right, I can actually write that as -2 over 1. And the reason why I'm going to do that is so that I'll know my rise and my run. All right. Now I'm going to go to my graph and I'm going to plot my y-intercept first. All right. Remember, that's the point 0, -1. And so if I go to my y-axis, go to -1, plot that point, and I have my y-intercept. All right. Now I'm going to use my slope in order to help me find another point that my graph goes through, or that line is going to go through. All right. Remember, this is rise over run. Now, when I think of rise, I think of going up. But since that is a -2, I'm actually going to go down 2, right? So that negative in front of that 2 tells me to go down 2. Had it been a positive, I would have gone up 2. Now that run is positive, and normally I run to the right. Normally we run to the right. Since it is positive, we are going to run to the right. Had that been a -1, I would have run to the left, all right? And so to find the other point, I'm going to go down 2 from this point. So I'll go down 1, 2, and then I go to the right 1, and I have this point here. And this point is the point 1, -3. And so now that I have my 2 points, I'm just going to draw the straight line that goes through those 2 points. and I have my equation of my line drawn. And so this is the equation y equals negative 2x minus 1. Okay? And that's how we graph using our slope and our y-intercept. The last thing I want to look at in this section is interpreting what the slope means. And we're going to look at this looking at an example. All right? It says the value, which we're notating with the variable y, of Dave's car X years after 2008 is given by the equation y equals negative 3,000x plus 25,000. Find and interpret the slope. Okay? Well, remember, when our equation is written in y equals mx plus b form, whatever is multiplied by the x is your slope. And so in this example, my slope would be negative 3,000. All right? And now what I want to do is interpret what that slope means. Well, back in when we first started talking about slope, we said that your slope explains the change in y given a 1 unit change in x. All right? Remember, your y in this example is the value of the car. And x is the years or the year after 2008. All right? So your slope is going to tell you how much the value of Dave's car changes X years after 2008. All right? And so since that's a negative, instead of that value of the car going up, it is actually going to go down by $3,000. All right? And so if I wanted to interpret this problem, I would say that Dave's car, the value of Dave's car will decrease by $3,000 each year after 2008. That is the interpretation of the slope. Notice I didn't say decrease by negative 3,000. The word decrease takes care of the negative part. All right? And so that's the interpretation of the slope in this example. All right? And that includes what we're going to talk about on this video as it relates to slope.